In this video, we take a look at the concept of subsequences of a given sequence. We're first going to model what subsequences should be. We're going to use that model to define subsequences. And then we're going to look at the connection between whether a sequence converges and its subsequences converge. So if we have a subsequence xn, the question is, what should a subsequence of that sequence be? As with many things, we're going to start with a model. I call it the toss-out model. What we're going to do is focus on how you would build a subsequence from a given sequence. So first, take the original sequence, toss out some of the terms of the original sequence, line up the remaining terms in the order according to the subscripts. In other words, we have the same terms, but we can't change the order of them. And then make sure that you haven't tossed out so many terms of the sequence that you don't have infinitely many terms left. So our original sequence is x1, x2, x3, etc., going off to infinity. Our new subsequence is x sub p1, x sub p2, x sub p3, etc. Remember that the terms that are in the same order, that means that P1 has to be less than P2, which has to be less than P3, etc. That means if we look at the PNs, that actually forms a sequence itself, and it's a strictly increasing sequence. So that leads us to our definition. Let xn be a sequence. A subsequence of xn is a sequence x sub pn, where Pn is a strictly increasing sequence of natural numbers. So for instance, if we have the sequence of the even natural numbers, 2, 4, 6, 8, etc., here are some subsequences. We can look at the multiples of 4, 4, 8, 12, 16, etc., the multiples of 14, 14, 28, 42, etc. We can look at all of the terms of the form 6n plus 2, we get 8, 14, 20, 26, etc. So now suppose xn is a convergent sequence. The question is, what can we then say about its subsequences? And it makes sense that if all the terms in xn are getting close to some limit L, that the terms of all its subsequences should be getting close to that same L, and we're going to prove that as a theorem. So let xn be a sequence that converges to the number L. If x sub pn is a subsequence of xn, then x sub pn also converges to L. And the proof isn't going to be too bad. So we're going to start with epsilon greater than 0, and we're going to find some big N natural number such that whenever little n is bigger than big N, we have absolute value of x sub pn minus L less than epsilon. So we know that xn converges to L, and that means there's some big N such that whenever little n is bigger than big N, then absolute value of xn minus L is less than epsilon. And since P1 is greater than or equal to 1, and the Pn's are strictly increasing, that implies that each Pn is greater than or equal to n for all n. In fact, the only way we can get the Pn's to be equal to n for any significant number is if we don't throw out any terms at all. So that means that for all little n bigger than big N, we have Pn greater than or equal to n, but remember, n is greater than n, and that tells us that Pn is also greater than n. And that implies that absolute value of x sub Pn minus L is less than epsilon, and that gives us our theorem, or gives us our proof. All right, so some conclusions. If we have a sequence that converges, that means all its subsequences have to converge as well. If we take the contrapositive of that, if we have a subsequence of a larger sequence that diverges, that means the larger sequence must diverge as well. Now we want to look in the gray area. What happens if we have a divergent sequence? What can we say about the subsequences of that? Do they converge? Do they diverge? Well, if we look at the example of negative 1 to the n, this is just a sequence that flips back and forth between negative 1 and 1. If we only look at the even terms of that, the even subscripts, look at all the even powers of -1, those are all 1, that actually converges. So we have a divergent sequence with a convergent subsequence, which suggests that if a sequence diverges, we can't make any conclusions about whether its subsequence converge. Maybe it has convergent subsequences, maybe it doesn't. All right, so that gets you ready for the in-class activities, the introduction to subsequences. That's just at the link below this video. Go ahead and click on it.